we have Lisa, Petra, Vegeta, Daniel, Enno. I'm seeing Enno, Anson, Francesca, Mawunya, and Nana. Welcome. Drozel, I can see you too. Okay, beautiful. So we started with mensuration last 2 weeks. We talked about the circle, we have talked about rectangle, we have then talked about squares and the triangles. Is that right? Hello? Hello? Please, can someone unmute for me to know that you are around? Oh, okay. That's nice. That's nice.
Yes.
Good. Okay, so we talked about a circle. Parts of the circle, we have talked about that. Then we talked about the rectangle, square, triangle, types of triangles. And today we'll be going on to the parallelogram. So we'll be doing much of the four-sided figures, okay? We'll be doing much of the four-sided figures, and the first four-sided figure we'll be talking about is the parallelogram, okay? So let's start very first. Okay, so a parallelogram is a four-sided plane figure which has its opposite sides being parallel, okay? It is a four-sided plane figure which has its opposite sides being parallel. So as you can see from the shape on the right-hand side, this vertical line and this vertical line are parallel. That means that if you move them, if you drop them to infinity, they will never meet. Is that okay? They will never meet. They always move in one direction, so they never meet. Then the base two, as you can see, they are also parallel, which means that if you draw them to infinity, they will also never meet. So that's what we mean by it has its opposite sides being parallel. Now the opposite sides are equal in length, and the sides are not at right angles, which means that they are not at 90 degrees. Is that okay? So the angles here are not at right angles, which means that they are not at 90 degrees. But there is a height that is drawn in the parallelogram that must touch the base at 90 degrees. That must touch the base at 90 degrees. So these are some few tips that you have to take care of. You have to understand them before we continue, okay? Any question? Okay, so let's continue. Now, a parallelogram, for the perimeter of a parallelogram, you sum all the lengths. As we already know, the perimeter is the length around any plane figure. So going around the figure, going around this parallelogram will give us the what? The perimeter of the parallelogram. And as you can see, we have one side here, another side here. We have one base here, we have another base here, which they are equal in length. Therefore, the perimeter of a parallelogram is equal to the sum of all the lengths. And when we talk about the sum of all the lengths, we are talking about two bases and two sides. Therefore, the perimeter of a parallelogram is equal to 2 times the base plus 2 times the side. I hope you are getting it. Okay, so that's the perimeter, 2 times the base and 2 times the side. A base, since they have the same length, you just pick one, multiply it by 2. The sides to have the same length, you pick one, multiply it by 2, then you get your perimeter. Now the area of a parallelogram is the base times the height. The area is the base times the height. Now you can see that I've written that. Note that the height must be at right angles with the base. The height must be at right angles with the base. Therefore, the area of a parallelogram is the base times the height. Is that okay? And the height must be parallel. The height must be right angled towards the base. The height must be right angled to the base. Okay. So that's for parallelogram. I'll be giving you questions and you solve them using Okay, so the area of a parallelogram is 48 centimeters squared. Its height is 4 centimeters. Find the length of the base, or find the base. I hope you can all see the question. Today you are going to do more of the solving, okay? Good, good, good. So the area of a parallelogram is 48 centimeters squared. Its height is 4 centimeters. Find the base. Who is done? Oh, okay, nice. The answers are coming in. Nice, nice, nice. Nice one, Rosel. Nice one, Lisa. Nice one, Brigitta. Nana, nice one. No, nice one. Daniel, nice one. Okay, beautiful, 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 beautiful. Beautiful ones there. Okay, so let's solve it. You have already solved it, but still let's solve it. So we have been given the area. The area of the parallelogram is equal to what? The base times the height. We have been given the area to be what? 48 centimeters squared. And the height, we have not been given the base, but we have been given the height to be 4 centimeters. So we have it is equal to 4b. Therefore, 48 divided by 4, which b will be equal to what? 12 centimeters. That will be what? The base. That will be the base. That will be the base. Okay, another one. Okay, let's use the whiteboard. The drawing is not up to standard, okay? Just putting something down. So with this side being 25 mm, and this side being being 37 mm. and the height is 19 mm. Okay, so find the area and the perimeter of the figure. Bridgetta, what device are you using? Are you using a phone or you are using a laptop?
A phone.
A phone. Oh, okay. Okay, then let me give you the figures, okay? The question didn't include perimeter. It was only area. Oh, shit. Okay, nice answers there. Nice answers there. Nice answers there. Well done for adding the perimeter. God bless you. Dan, Daniel, I'm not seeing you. Today you are representing the guys. So, eh? Today you are representing the guys. Oh, he's not online anymore. Let me check. Daniel is online. Daniel, you are representing the guys today, please. Okay, so since we all had it correct, we will continue. Okay, you just fixed it. Okay, nice one, Mawunya. Nice one there. Nice one there. So that's it. Any question out to this stage? Any question? Hello, any question? If no question, give me a no in the comment section. Nice one, Daniel. Okay, okay, okay. Nice one, nice one, nice one. Okay, so we move to the next shape, which is a rhombus. The next shape, which is a rhombus. Now, a rhombus is a parallelogram. Is that okay? A rhombus is a parallelogram, but it has all its sides equal. So it's like a rectangle which has two sides equal and the other two sides not equal. For the parallelograms is the same thing. It's like a rectangle that has been slanted. Then the rhombus is like a square that has been slanted. Okay, so the rhombus has all its sides being equal. As a square is a rectangle which has all its sides being equal. It's the same thing here. Now the diagonals bisect each other at right angles. The diagonals, they bisect each other at right angles and also bisect the opposite angles. So as you can see, these diagonals, these two diagonals in here, they bisect each other at right angles. So these angles that they are bisecting here is what? 90 degrees. It is 90 degrees. So even if it is not given to you, you have to know that it's what? 90 degrees. I hope it's clear. Even If it is not given to you, you have to know that it is 90 degrees. Now, and they also bisect the opposite angle. So as you can see, this line moves and bisect this angle here. Let me use that notation. It moves and bisect this angle here, as well as it bisect this angle here. This diagonal also bisect this angle here, as well as it bisect this angle here. Is that okay? So that's what you mean by the diagonals bisect each other at 90 degrees, which is this side. And also bisect the opposite angles, which are these ones. Now the opposite angles are equal. The opposite angles are equal. That's for a rhombus for you. Okay. Now for the perimeter of a rhombus, it's very, very simple. It's like the perimeter of a square. You know all the lengths are the same. Therefore, if you have one length, you can just multiply it by 4 to get the perimeter of the rhombus. So that's how you find the perimeter of the rhombus. Then for the area of the rhombus, it is length of the base. That's length of one of the lengths. Length of the length of one of the length of the base. Exactly. The length of the base, which is this one, times the height. So the length of the base times the height. That will give you the area of the rhombus. Exactly. Or another formula is half of the product of all the diagonals. Now, in some questions, the length will not be given to you, but the length of the diagonals will be given to you. Now, in such an instance, if the length of the diagonal is given to you, you use this formula, which is half of the product of all the diagonals. Half of the product of the diagonals. So let's pick an example. I don't know how this lady will see it, but this drawing is not up to scale. Okay. Now the length of this one, is 4 centimeters. The length of this side is also 4 centimeters. The length of this diagonal is 2.5 centimeters, as well as the length of this diagonal. This diagonal is also 2.5 centimeters. Find the area of the rhombus. Find the area of the rhombus. Okay, nice one there, Nana. Nice one there, Eno. Nice one there, Lisa. Nice one, Daniel. Nice one, Petra. Okay, so let's solve it. Okay, so the area, the formula for finding the area, if you are given the diagonals, is what? Half times the product of the diagonals. Is that okay? Half times the product of the diagonals. Now, as we can see, we have one long diagonal here and another long diagonal here. Just that their lengths have been broken into two. Is that okay? Therefore, we have to find the length of this four diagonal, find the length of this diagonal before we multiply them. Therefore, the length of the first diagonal will be 4 plus 4. And the length of the second diagonal will be what? 2.5 plus 2.5. 4 plus 4 will give us 8. And 2.5 plus 2.5 will give us what? 5. Is that okay? So you multiply 8 and 5, and that will give you what? 40. Now the formula is half of the product of the diagonals. Now we have been able to multiply the diagonals, which is 8 and 5. Now what we need to do is to what? Divide it by 2. And that will give us what? 20 centimeters squared. Any question? Any question? Hello? Please, any question? If you don't understand, give me a hi. So that I go over it again.
Sir, please go over.
Okay. So what I'm saying is that the formula is half times the product of the diagonals. And the diagonals in this figure is from this point. It's from this point. So this point, that's one diagonal. Then another diagonal. Then another diagonal. And I'll come back to you, okay? Okay, so one diagonal is from, I hope you listen to this one. It will answer your question. This is the figure, okay? And one diagonal moves from this side to this side. So it doesn't stop in the middle, but it extends to the other end. Is that okay? And for this other diagonal to start from this side, doesn't stop at the end, but extends to this side. Is that okay? Therefore, we actually have two diagonals in this shape. Just that the what is it called? The value for the length for each of the diagonals have been broken into two. From the end to the center and from the center to the end. Now, when we're doing circles, you could see that for the radius is from the center to the circumference of the circle. But the diameter is from the circumference to the circle, passing through the center of the circle to another circumference of the circle. Exactly. It's the same ideology here. This diagonal line is working as a diameter. It moves from one side of the shape then ends at another side of the shape. Just that it wasn't given to you in the form of what? A diameter, but it was given to you in the form of a radius. Now, if you have your radius and you want to find your diameter, what do? You just have to add the two, the radius, or you multiply the radius by 2. Then you get what you want. So let's use that ideology of circles here. So if I want to find the diameter, I have the radius, which is what? 2.5. And as you can see, the figures are the same, 2.5, 2.5. Maybe you could have 2.5 and 3. You will still have to add them together. Is that okay? You still add them together. Then multiplied by, the same applies to the 4. So 2 by 4. As we are having 2 of them there, so we're having 1 4. We are having 1 4 and another 4. We are having 1 2.5 and another 2.5. Therefore, 2 times 2.5, then 2 times 4. 2 times 2.5 will give us 5. Then 2 times 4 will give us what? 8. 8 times 5 will give us what? 14. Therefore, half of the product of the diagonals, this is the product of the diagonals, that's 5 times 8 is the product of the diagonals. Therefore, half of the product of this diagonals, which is 40, will be what? 40 divided by 2, and that will give us what? 20 centimeters squared. Thank you very much. Nice one there, nice one there. Any other question? Any other question?
Sir.
Any other question?
Sir.
Yes.
Please, with the rhombus, if you are given, no, with the trapezium, if you are given only the length of the two parallel sides and you're asked, and the height too, and you're asked to find the perimeter, how will you do it?
Then in such an instance, you have to find the side, the two sides first. Let me move back to the trapezium, then I can explain it better there. Okay. Okay, so this is the trapezium, okay? And you are given the length of these two parallel sides. You are given the height, and you are asked to find what? The perimeter, right? No, I don't think the examiner will be such cruel, because you'll be doing some lots of unreasonable calculations here. Is that okay?
Yes,
So
please.
at least you'll give you one of the size.
Okay.
That okay? At least, to trick you, you'll give you 3 size plus the height. Is that okay? Lisa?
Yes.
Yeah,
Yes.
at least if the examiner wants to trick you at all, he'll give you one the size of the two parallel, then we'll give you one of the size. Then since you know that this side is equal to this side, you just use it for it and go on.
Okay, thank you.
Good.
Yes.
You're welcome. Yeah, so what if the diagonals were? Yeah, if the diagonals were not equal. It's asking if the diagonals were not equal. Is that okay? So if the diagonals in the rhombus, inside the rhombus, are not equal, you still add them. Is that okay? You still add them because it adds up to one long diagonal. And we are not talking about this short one. This short diagonal does not fit the description of the diagonal bisecting each other, then also bisecting the opposite angle. As you can see, this short diagonal only bisects one opposite angle and doesn't even bisect any other one here because it ends in the center. Therefore, if the diagonals are unequal, you add those numbers to get the length of the 4 diagonal, then you deal with it from there. I hope you get it now.
Yes, please.
Good, good. That's nice. That's nice. Okay, so that is rhombus for you. The last one that we will talk about today is kites. Kites. I managed to draw a kite for you. I managed to draw a kite for you. So it's not up to standard, but I hope you will take it like that. So a kite is also a four-sided figure in which two pairs of adjacent sides are equal. Is that okay? Two pairs of the adjacent sides are equal. Two pairs of the adjacent sides are equal. Therefore, if you can see from this figure here, we have from this side to this side being equal. That's my annotation. We have from this side to this side being equal to from this side to this side being equal. That's what we mean by two pairs of the adjacent sides being equal. So this side to this side are equal, and this side to this side is also equal. So you can say that the base part is equal and the top part too is also equal. So that's a kite for you. Now the diagonals bisect each other at right angles. That means that 90 degrees also. Okay, at right angles. Then they also bisect their angles like the rhombus does. Okay, they also bisect their angles like the rhombus does. I didn't add that one. Okay, so that's a kite for you. Now, for a kite, the perimeter is the sum of all the lengths of its four sides. So perimeter, you just add up all the lengths of the four sides. Then for the area of a kite, it is the half by the product of the diagonals. For the area of the kite, half times the product of the diagonals. Is that okay? So it's like the rhombus. It's like the rhombus, but just that the rhombus, you have an alternative method for finding the area if you are given the length and the height of the rhombus. Is that okay? You have an alternative to use the length by the height of the rhombus or half times product of the diagonals. But for the kite, it is what? Half times the product of the diagonals. That is the formula for finding the area of a kite. Is that okay? So from this point onwards, you'll be doing a lot of calculations for me, and I'll be doing a lot of wow, nice work done, good work. We will be combining from circles, rectangle, square, triangle, parallelogram, trapezium, rhombus, and kite. We'll be combining them, okay? And we'll be solving a lot and lot of examples. So let me open a new slide and let the first one be a kite. Give me a second, please. Hello. So this is your kite, and this length it's 8 centimeters. This length is also 14.4 centimeters. Now for this one is 6 centimeters. You have to find the area of this kite. You have to find the area of this kite. As you are solving.
Sir,
Yes.
please, with the kite, the 6 centimeters, is it for the whole diagonal?
No, it's for only that side.
Okay, thank you.
You're welcome. Nah, nice one, nice one. You have tried. Nice one there. Nice one there. But you can try it again, okay? There's no harm in trying again. Nice one there, Lisa. Nice one there, Nana. Anyone else? Anyone else? Anyone else? Nice one there, nice one there, Francesca. Roselle, nice one there. Okay, so let's solve. Okay, so let me use this one. Now the area of the kite is equal to half of the product of all the diagonals. Okay. So as I was explaining, when we were doing the rhombus, I talked about using the full, let's say the diameter, okay, or using the full length of the diagonal and using the full length of this diagonal too. Okay, so the full length of the longer diagonal will be what? 8 plus 14.4. And the full length of the shorter diagonal will be 6 plus 6. Now, the other 6 was not given because, as you can see, in the kite, the top side is longer than the downside. That makes it that the length of the top will not be the same as the length of the down. But if you can look carefully, you could see that this side and this side are equal. Therefore, only one of them was given, that is 6 centimeters. Therefore, you have to know that the other side is also 6 centimeters. Unless it is given to you, you should know that the other side is equal to the first side that has been given to you. That's why when I was talking to Lisa, I told her if the examiner wants to trick you, that's what you'll be using. So you have to have it in mind, the shapes that are parallel, the ones that are equal, the ones that are unequal, the ones that meet the height that meet the base at 90 degrees, circumference of the circle. You have to have all those in mind so that when you see something, you'll be able to relate to it quickly and use it to solve the question. I hope you are getting it. Okay, so with the first one, the product of the longer line, it will be 8 plus 14.4. That will give us what? 22.4. Then 6 plus 6, that will give us 12. I hope you are following. I hope you are following.
Yes.
Okay. So this, when you multiply these two, you are going to get what? 2. Now, we are not done. The formula says half of the product of all the diagonals. Therefore, we have already found the product of the diagonals. All we need to do is what? Divide it by 2. That will give us half of that. So, area will be equal to centimeters squared. Well done. Any question? Any question? Okay. So now the next question is already there for you. And try your hands on it. From there, we'll move on to something a little complex.
The area.
I'm not, Drizzle, I'm not hearing you well.
only the area or both the area and
We are finding the
trapezium?
perimeter and area.
Okay, so
Perimeter of them. Okay.
yeah.
Nice one. I'm getting beautiful answers. And now you are finding the area and the perimeter of the shape here, the trapezium here. Okay.
Okay.
Nice one there. Nice one there, Nana. Nice one there, Drizzle. Lisa, nice one there. Keep the answers flowing. Oh, nice one. That is a good though. That is a good. Nice one there, no. Nice one there. I'm seeing more of area. Let me one there. Okay, Nana's running the perimeter. Nice one there. Nice one there, Nana. The rest, I'm waiting for your perimeter. I'm not seeing it. Nice one, Daniel. Okay, so let's solve it. Let's solve it. So for the area, as you know already, it is about what? Half of A plus B times the height. So we know that our A plus B is 8 plus 11. Then times the height, which is 7 centimeters. So 8 plus 11, which will give us 19. Nice one there. Times what? 7. Half of 19 will give us what? Hello, anyone around?
Yes.
I thought you have all left me. Okay, so half of 19 will give us what? Okay, I'll put in my thing there. 9.5 times 7. And that will be giving us what? 66.5. Is that okay? So that's for the area, 66.5 centimeters squared. Let me add it. Then for the perimeter, we add all the sides. That's we have 8, we have 6, we have 11, then we have 6. As you can see, this side and this side are equal. That's what makes a trapezium unique. Okay, so 6 and this place too is 6. So you add them together, you add your 11, you add your 8, then you get what?
31.
31 or 32? 81. Beautiful, 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 beautiful. I'll give you 31 centimeters. So that's it. Okay, that's it. Let's pick our last question. Let's pick our last question. I'm trying to modify a certain question here. Let me try and modify this question. Oh, so I covered the sec. Okay, so this is your question. And The length from here to here and the length from here to here are both 10 centimeters.
I don't understand.
Okay, so these two lengths are both 10 centimeters, okay? Find the area of the shaded region, and I'm about to shade the shaded region for you right now. Okay, so you are finding the area of the shaded region. You can start work. Let me bolding it for you. Oh, let me use it like that. Okay, so you have to find the area of the shaded region. Let me open my comment section and relax for the answers. Nice one there, nice one there, nice one there, nice one, Eno, nice one. Lisa, nice one, Francesca. Keep the answers coming. I'm not going to Yeah, Rosa, you have your hands up. Let me unmute you. Rosa, you can unmute yourself and ask the question.
Please, I've gotten it.
Oh, okay, okay, that's nice. Nice one, Maunya. That's one, Daniel. Nice one, Drozel. Okay, so let's solve it. Then we bring today's class to an end. Okay, so the question is to find the area of the shaded region. Okay. Now, for the area of the shaded region, we have two kinds of figures there. We have a square and we have a circle. The circle is inside the square, and the shaded region is the part of the square that the circle does not cover. Therefore, all we have to do is to find the area of the square and subtract the area of the circle from it. Okay. So, the area of a square is length times length. And we know that our length is 10 centimeters. So 10 by 10, that will give us what? 100. Then minus the area of a circle, which is what? Pi r squared. Let me use x to represent it. Pi r squared. So we'll be having 100 minus our pi is what? 22 on 7 by our r. Our diameter is 10 centimeters. Therefore, our radius will be what? 5 centimeters. 5 squared. Okay. So we have 100 minus 22 over 7 times 25. And that will give us 100 minus 20 over 7 times 25. That will give us, I think, 34 points over 7 by 25. That's 78.557. Is that okay? So minus 100 will give us 21.43 centimeters squared. So that's the area of the shaded figure there, and I'm glad you all had it. That means that you all have gotten the concept here and you understand it very well. I would like us to do one last one, but since our time is almost up, so I'll give it to you as an assignment next week when we can, before we move to the next topic. We will try that one. Okay. So for this one, okay, so this is the figure. Nice one there. Okay, so the base of the triangle is 7 centimeters. I'm not writing this one, so draw it then. After that, I'll be giving you the figures. Or let me try putting it there. area of the region outside the triangle. Okay. They touch the circle. They touch the circle. I'm trying to make them touch, but okay, yeah. They touch the circle. Every side of the triangle touches the circle.
Yeah.
So you have to find the area of the region outside the triangle. Is that okay? The area of the region outside the triangle. Any question? Okay, any question? Hello? Hello, hello, hello.
Hi.
Aha, nice, nice, nice. Any question?
No, please.
Okay, that's nice. So that ends our lesson on mensuration. Okay, that ends our lesson on mensuration. You can pick the past questions and pick the examples in there and solve them using the various formulas that have been given you. Okay, it's the same thing there. When you see any plain figure which is very complex, like you haven't seen some before, just look at the figure very well, then look for the aspect of the figure which may be a triangle, the aspect which may be a circle, the aspect which may be a rectangle, a square, and etc, etc. Find the ones that you have figures surrounding them, then solve that one first before you can be able to solve the original question. Is that okay? So that's mostly the trick that we use in solving such questions. Is that okay? So that's mensuration for you. It's been nice having you through this lesson. Thank you very much.